distinguished Dr. R. Rao and family members of Dr. N.V.R.L.N. Rao, past chairman, committee members of Institution of Engineers, Telangana State Centre, fellow fraternity, budding engineers, media friends, ladies and gentlemen. Today, I am very happy and consider it a great honor to be amidst this august gathering and extend a hearty welcome to all of you, Dr. N.V.R.L.N. Rao, third endowment lecture on challenges in underground construction for Meytro through congested area to be delivered by Professor R.S. Gandhi. It is the honor bestowed on us, Professor S.R. Gandhi, who have very kindly and spontaneously conveyed consent to grace this function and to share their rich experiences.
Thank you.
I am very happy to inform that Dr. N.V.R.L.N. Rao, former professor of Department of Civil Engineering, Usman University, requested the Telangana State Centre for instituting annual endowment lecture in his honor on his birthday every year. Today is Dr. N.V.R.L.N. Rao day. Sir, wish you happy birthday, sir, and many returns of the day, sir. The Telangana State Centre Committee at its meeting held on 27th January 2018 was unanimously resolved to organize an endowment lecture annually in honor of veteran engineer Professor N.V.R.L. Rao Garu, who contributed in the field of engineering education. Accordingly, the first endowment lecture was organized on 26th October 2018, and second endowment lecture was also organized on 26th October 2019. Today, the third lecture is being organized, that is 26th October 2020 through webinar. I take this opportunity to say a few words about Professor N.V.R.L. Rao Garu. The Professor Rao obtained a BSc Engineering Civil and ME and PhD Geo Engineering. He was a professor in Civil Engineering, Birla Institute of Technology, and Bihar, Ranchi, Bihar, and at Usman University, 1971 to 1974, and on superintending the relinquishing the professor at Usman University. Since 1959, involved in teaching and research and consultancy in geotechnical and covering site investigation and soil investigation foundations and civil engineering structures. And he visited USSR in 1962, USA, UK in 1998 as a tourist and interacted with some academicians there. We are very happy to inform that Telangana State Centre of the Institution of Engineers felicitated him as eminent engineering teacher on the occasion of Teachers' Day on 5th September 2018. I am very glad to inform that Telangana State Centre of the Institution of Engineers has been regularly organizing the endowment lecture every year on the birthdays in honor of the eminent engineers like Engineer V. Subbarao on 26 January and M. Tirupati Reddy on 4th February, Dr. J. Purushottam on 1st March, and Koga Krishna Mohan Rao on 23rd April, G. V. Subbarao 19th June, T. Hanmant Rao on 21st June, and A. P. Ranganath Swamy on 27th July, Dr. S. Raghavachari on 15th August, and Dr. Narla Tatharao on 4th September, and Engineer Mathur Gopal Rao on 10th September, Gurram Koti Reddy on 23rd September, and Atlur Venkateshwara on 28th September. Now today, 26th January, we are celebrating Engineer RL, that is our Dr. N.V.R.L.N. Rao on 26th October. and engineer L. Venkata Krishna Iyer, and KV Srinivas Rao, and ML Swami on 19th November, and A. Ramakrishna on 21st December, and also Engineer I. Basuraj on 30th December. The endowment lectures are being delivered by the people of high eminency with the considerable professional experience to throw light on the important emerging topics of today's relevance. I'm very glad to share a few words about the Institution of Engineers for information of the chief guest, today's speaker. The engineering fraternity of the nation may feel proud to have the professional body like Institution of Engineers India and established and serving the fraternity more than 100 years, and establishment of institution is interlinked with the history of the modern day engineering and persist demand of the nation to all round the engineering activities throughout the length and breadth of the country. The Institution of Engineers is the largest professional body and encompasses 15 engineering disciplines and gives the engineers a global platform from which to share the professional interests. IEA has membership strength more than, including corporate, non-corporate, 10 lakhs. I am very happy to inform that the Institution of Engineers completed 100 years of its service in the engineering advancement for the nation buildings, and culminated the function of the centenary celebration of the Institution of Engineering was held in 13th September 2020. Since you're all anxiously waiting to hear the talk from our eminent speaker, I'm limiting myself. I hope we will all enjoy the talk on behalf of the government of, on behalf of Telangana, the Institute of Engineers, the Telangana State Centre, and my own behalf, I extend hearty welcome to all of you to this important endowment lecture. Thank you, one and all. Now, I am requesting Professor Dr. Ramna Nayak Banoth, FI, a Joint Honor Secretary, Institution of Engineers. Please introduce today's chief guest and speaker of today's endowment lecture, Professor R. Gandhi, Director, Sardar Vallabhai National Institute of Technology, Surat. Over to Dr. Ramna Nayak Banoth.
హలో సార్ రమణానాయక్ గారు మ్యూట్ చేసుకోండి మీరు సార్.
Okay.
Ramna Nayak Banoth.
Yes, sir. Coming. One second.
Please.
I'm unmuting, sir. Sir, thank you, Chairman, sir. It's a great privilege to introduce our Honorable Eminent Professor, Sri Professor S.R. Gandhi Garu, Director, Sardar Vallabhai, NIT, Surat. Professor S.R. Gandhi Garu obtained his BTech Civil from Saurashtra University in 1977, MTech in Soil Mechanics and from IIT Madras in 1979, and PhD on topic of the pile socket in the Vikraf from IIT Madras in 1985. He worked as a faculty in Ocean Engineering Center at IIT Madras from 1982, and since 1990 he was a faculty member of the Geotechnical Engineering Division, Department of Civil Engineering, IIT Madras till October 2016. Since 24 October 2016, he is a director, SVNIT Surat. His research area includes the design of pile foundation, ground improvement, field instrumentation and monitoring, and design of ash bond. He has carried out of 3 major sponsored research projects funded by the Department of Science and Technology, definitions of the fly ash and reinforced earth embankment. He is an active foundation consultant of various government organizations and private industries for design of the construction of a foundation. He served as executive member of the Indian Geotechnical Society, Delhi, for 2 terms. He was the organizing chairman for the Geotechnical Conference 2006 and Deep Foundation Institute of India Chapter Conference 2012 held in IIT Madras. He served as the chief editor of the Indian Geotechnical Journal during the 2005 to 2010 and also served as a associate editor Sadhana Journal. He was the institute chairperson of IIT Madras. Thank you, sir. Hearty welcome to Professor S.R. Gandhi Garu, and thank you. Happy birthday to my Guru, Dr. N. Rao sir. Thank you, sir. Thank you, sir.
Yes. So now over to our today's chief guest and today's speaker of endowment lecture, S.R. Gandhi. Please, sir, start your talk, sir.
Namaskar. Very good evening. Am I audible?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Okay. Are you able to see the cursor I'm moving on the slide? Is my
Yes,
presentation?
sir. Yes, we are seeing, sir.
Okay. Okay. So, Dr. G. Kameswar Rao, the President, Function and Chairman of Institute of Engineers, Telangana State Centre, Professor Ramanayak, Joint Honorary Secretary of Institute of Engineers, Telangana Centre, Engineer T. Anjaya, Honorary Secretary of IEI Telangana State Centre, Professor Ramana Rao, Director of NIT Warangal, various learned participants, the geotechnical background of attending this webinar, all invited guests, ladies and gentlemen, a very good evening to all. I recollect my first visit to Institute of Engineers Auditorium at Kharidabad in 1981, when the Indian Geotechnical Conference was organized there. And I was that time a PhD student working under Professor V.S. Raju. And I had published a paper along with him on rock-supported pipe out of my PhD work. In my career, I have spent considerable time in Andhra Pradesh in various geotechnical issues. We were designing the foundation for Godavari and Nagarjuna fertilizer at Kakinada. Then we did a lot of work of ground improvement at Vizag for VREP and many other projects, including port and other power plants at Vijayawada, Mudunur, and Rayalaseema, etc. So it's always a lot of learning experience in Andhra Pradesh. I am happy that today I have been given the opportunity to talk to the geotechnical fraternity through this program in this lecture. Let me convey my regards to Sri NVRLN Rao. And also to the Institute of Engineers Telangana State Centre for this opportunity. I'll be sharing some of my experience related to the construction of diaphragm wall, particularly when you want a deep excavation in congested area. So without taking much of time, I'll go to the next slide. This is what will be scenario if you do not have a diaphragm wall. There are a number of projects with 2 or 3 basements carried out in open excavation with a required side slope. This excavation you see is for the first research park, which came up next to IIT Madras campus for the Tamil Nadu and Electronic Corporation of India, Tidal Park. So as you see, if you have a luxury of space around the building, the open excavation is much simpler to execute. And then you have any strut-free approach to the construction site in arranging the foundation construction. Of course, the dewatering and slope stability, slope erosion, etc. has to taken care. The proper open excavation is the volume of earth you need to remove, and also backfill is quite high, which is almost negligible in case of the diaphragm wall. And other problem is what you see here, the line of trucks moving excavated soil out. And with traffic restriction in metropolitan city, this is another challenge that you have to transport it only at specified hours. The slope also, because you are constructing 2 or 3 basements, it may take more than 1 year, and it may be subjected to 1 or 2 monsoons, so it has to be protected properly against erosion. All these issues can be minimized or eliminated if you go for a diaphragm wall, RCC diaphragm wall. So the applications of diaphragm wall is mainly for waterfront structures in ports, but it is also extended in making the deep excavation in congested area very simple and quick. You see 2 types of use. One is temporary purpose as a seat pile, and the permanent structure is constructed within the diaphragm wall, and the diaphragm wall is left out unused. The other possibility is you use diaphragm wall as a permanent wall of the basement. Both applications are being used. In multi-story basement, it is used as wall, and diaphragm wall has also been used as a load-bearing element. When we use it as a load-bearing element, it is called barrette, and many of the new metro construction has used barrettes as a supporting column for roof of various floors in the underground station. It's also used for underground facilities like belt conveyor, wagon tippler, water sump, and also as a barrier for control of seepage of water or leachate in a municipality solid waste dump or other harmful waste dump. The common shapes of the diaphragm wall section is the most popular is rectangular because the construction is simpler here. The length of a panel varies anywhere from 2.5 to 4 meter, sometimes even wider if the equipment for handling larger size reinforcement cage is available. But normally it is 2.5 to 4 meter. Width is typically minimum 0.6 meter to up to 1.2 meters. And depth up to 25 meter have been executed without much difficulty. And in some cutoff, it has gone to deeper level also. Apart from rectangular section, the T section is also very commonly used where you have larger depth of excavation and you want to avoid struts or anchors because it has higher moment of resistance. So you have a T section. L section is used more for the corners of a berthing structure in a port, and the plus section is used as a barrette for a load-bearing element, as I mentioned earlier. The construction of a diaphragm wall panel is more or less same or similar to what we have for board cast in situ pile. You have the same temporary support at the ground, then excavation or grabbing from this temporary support, and then you have bentonite slurry stabilization and lowering of reinforcement cage, cleaning the bottom and trimming concreting as in case of a broadcast in situ pile, we will see with the pictures some of these operations. I already discussed the stability of trench wall is very important in diaphragm wall construction. Other important thing is water tightness of the joint between the two panels of diaphragm wall. So if this is not there, you will have a lot of groundwater seepage into the basement or underground railway station and all, which needs to be tackled. You need to embed the diaphragm wall in rock sometimes, so you need special tool for cutting the trench in rock. And many places you prefer a strut-free excavation. So up to certain depth, it is possible using the T-shaped panel. And there are various claims for extra consumption of concrete if the soil investigation is not right, and if there are collapses observed which is not foreseen from based on the soil data. So when it is used as a basement wall for underground metro station or a basement of a building, it's also important to have a monolithic joint with the foundation floor. So this is one of the point in the diaphragm wall construction. Trench construction. In broadcast in situ pipe, as you see here, there's a casing pipe through which you carry out the soil boring. But in case of diaphragm wall, what you see in the background here, it's a linear structure extending to 50, 100 meters or as per the requirement. To cut this trench in the ground, we need a temporary support on either side, which is provided by two L-shaped concrete section, as you see here. It's an RCC L-shaped structure like a steel angle, which is provided on both sides, and the distance between the flange is equal to the thickness of the diaphragm wall. So the first step is to construct a small trench, prepare this concrete pre-trench, and then the tool can operate between the pre-trench, between the two L-shaped sections to cut the soil between the two sections. So here you see a typical view of a hydraulic grab, which is used to cut the diaphragm wall panel. There are two pre-trenches here between which the soil is grabbed and removed. And there are different types of equipment available for cutting the trench. The trench, as you cut, it has to be stabilized with bentonite slurry. So you always find the diaphragm wall site muddy or messy like this with all excavated soil and slurry spilled around. There's another type of normally 500 to 600 mm thick. So that's why you need minimum thickness of 600 mm for operating this tool in pre-trench. Now this is an old system where you can have the grab operated through a wire line. It's not so much desirable because you have less control on the orientation of it. And there are chances that as you go deeper, it may not maintain the orientation in line of the diaphragm wall. It's very rarely used now. So these are the powerful diaphragm walling tool which has a width of 1 meter and it can penetrate 15-20 meter deep below the ground. What you see the attachment here is having a telescopic section like the aerial in your 2-in-1, and as it penetrates in the ground, a smaller section emerges out. This closer view of the grab, which I just now mentioned, usually the width of the width of this grab is equal to the chosen diaphragm wall panel. So you can bite the entire length in single go, and the width of the grab is equal to the required thickness of the diaphragm wall, slightly less than that. And what you see here, white wire-like thing, is the polymer which is sticking as the grab is taken out from the ground. The polymer is used for commonly to stabilize the trench. The advantage is that soil can be separated easily from polymer and it can be reused for stabilizers. You have less of muck to be disposed with polymer. You also have a rotary method for diaphragm wall cutting. So you see here the pre-trench, which is in a T shape, and the boring tool, which you see here, rotates at certain speed. It has a cutter below, and the entire tool is moved in the direction of either the web or the flange, cuts the trench accordingly. So what you see here is the cutting tool, and this is the rod which you saw in the earlier slide. The cutting tool is operating at the rock level or hard strata. It has a lot of sharp edge carbon tungsten tips, and bentonite slurry is sucked from this mouth here. So the reverse mud circulation. There's high capacity pump, which you will see in the next picture, which sucks the bentonite from the trench at high velocity, and all the cut material is sucked by the bentonite, which moves up in this pipe, which goes through the pump, and it is thrown out at the disposal site. What you see in the background is the Vijayawada thermal power station at Ibrahimpatnam, where this diaphragm wall trench is made for a cooling water sump. So here you can see more clearly the entire trench cutting machine. You have a rail on which the rotating tool moves. This is the drilling rod which goes down to 10, 15, 20 meter depth where cutter is there. The machine is mounted on a frame which moves on rail with these wheels. You have this system for rotating the tool, and you have a high capacity mud circulation pump which sucks the bentonite from the trench along with the cut material. And the imperial of this is designed such a way that stones or rock pieces up to 25 to 40 mm can be handled by it and thrown out as a muck disposal. So that the machine keeps moving back and forth till they complete one depth and then advance the depth and repeat it till you reach the required embedment in rock. So there are other types of devices also used for trench cutting. This is rotary device where you have two rotary cutters, as you see in this picture, gray in color, and this rotates in the opposite direction. This rotates clockwise, this rotates anti-clockwise. So the cut material is led into the central portion up, and a high capacity pump, mud pump here, sucks the cut material and takes it out to the surface to the required disposal point. So here also the width of this frame is equal to the width of the panel of diaphragm wall required, and the thickness of the cutter is same as the thickness of diaphragm wall. This is faster in operation because you don't have to move the tool up and down. it keeps going down and it advances the trench without necessity of pulling it out. So here you can see a pictorial view of the rotary cutter. There are two cutters with a sharp edge, sharp tooth here, and this is the mud pump which picks the cut material. This will be lowered inside the trench up to large depth of 15, 20, 25 meters. And the discharge pipe attached to the pump brings the material to the surface and it is disposed. Another view of the same cutter, you can see here the hard tungsten carbide teeth. If it gets worn out, this can be replaced with a new one, sharp one, for effective cutting. The other difficulty we mentioned was about maintaining the cover. The diaphragm wall reinforcement cage is so heavy, and though the cover blocks are provided like in board cast in situ pile, if the ground is soft, the cover block penetrate into the soil, and then in result you will not have a required cover, which makes this reinforcement get exposed. And if it is marine environment, it will get easily corroded, and then you will have probably a reduced moment of inertia or collapse. So this should be avoided by carefully lowering the cage. Water tightness between the joint is also important for basic, especially for underground basements and metro stations. Here you see excavation made to check the joint between the two panels. If the panels are cast with proper care, you will have a very tight joint. And later we will see in the different slide how to make this waterproof. Like we provide a rubber stopper in construction joints, you can also provide rubber stopper between the two diaphragm wall panel, and it is always provided wherever water tightness is essential. So here you see a trench which is a panel which is already cast with a concrete, and here you can see the rubber stopper. There are two number of them, and what I have not discussed is the end stopper, what you see on either side of the diaphragm wall panel. So you have two options for casting a diaphragm wall. Either you go by alternate method of construction, where you cast one panel by having end stopper on either side, and then after this panel is completed, you don't take up the next panel, but go to the alternate panel, again using two of the end stopper. After the primary panel with end stopper on both sides is over, you can take up this for execution, where you don't need any end stopper because on either side you have a completed panel. The purpose of the end stopper is to make sure that the tool which is lower inside, it operates only between the specified distance between the stopper, and it doesn't make the panel
Hello.
wide.
నాకు రావట్లేదు ఇక్కడ సౌండ్.
So it's a flat diaphragm wall. This is a picture of one of the metro construction in Chennai, where the width of diaphragm wall is 1 meter. So you see the end stopper section, which is 1 meter wide, and it gives a profile like a trapezium. And the groove is provided in the end stopper to place the rubber stopper, PVC rubber stopper in this, and it's lowered after the required cutting is over. Another view, closer view showing the groove through which the rubber stopper is inserted. This end stopper, the lifting hooks here to lift it and lower it in the panel. Here the end stopper is being lifted to lower it in the excavated trench before concrete. So it's like a formwork on two sides. It's also possible to use precast diaphragm wall. Like we use precast driven pile, you make the trench cutting with the bentonite and then get a precast section of the diaphragm wall, which is lowered in the trench, which is already cut with bentonite. And each panel will have a profile like this. So this portion is grouted after placing both these sections, so it becomes a waterproof joint. No rubber stopper required here. Coming to the reinforcement of the diaphragm wall, this is a typical reinforcement cage for 1 meter thick diaphragm wall with a 4 meter width for one of the berthing structure. You can see the size of the cage. In pile reinforcement, you can have the reinforcement in 2 or 3 length, which you connect one after the other as you lower. But in diaphragm wall, because of large number of main reinforcement bars involved, making so many lap joint is difficult, and it's always made in one go and then lowered with a large boom crane. You can see here the cover blocks, the gray in color, and there are diagonal steel here, which is provided on all 4 sides. This is to make sure that when the cage is lifted, it may be weighing 20, 30, 40 tons and not get skewed under the weight. So the diagonal steel acts as a bracing to keep the stage stiff when it is lowered inside. Similarly, this is an L-shaped diaphragm wall panel. This is for a fertilizer berth at Paradip Port. And this is reinforcement cage for a T-shaped diaphragm wall. Same again, diagonals and cover blocks you can see here. So this is again at Vijayawada. This is the cooling water intake from Krishna River at Krishna Barrage. And from here, the water is pumped into the canal, which goes to the Ibrahimpatnam thermal power plant. So this depth is some 15 to 20 meters to get the required water depth for the pump to operate. And they didn't want any struts or anchors. So L-shaped diaphragm wall panel is used. What you see here is the flat section of the T-shape, and the web of the T section is behind, embedded in the soil. So these are other applications of underground construction like wagon tippler, where you make use of diaphragm wall. Here it is strutted wall. So you can see how much congested struts are there, and doing any construction through this strut will be very difficult. That is why most of the underground metro stations prefer not to use the strut, but to go for what we call top-down construction. We will discuss it a little later. So I will skip some of these pictures. You can have this as an example of strut-free structure. This is 3-basement excavation made for one of the hotels in Chennai. And this is diaphragm wall panel. You can see the width is about 5 meters. You can see the construction joint between the diaphragm wall connected with a coping beam. It's not cantilevered, but it is provided with one row of anchor at the top through the coping beam. The anchor is going 45 degrees towards the land and holding the diaphragm wall. So the construction becomes much simpler in the absence of the struts. I'll now come to some of the experience with the Chennai Metro, where diaphragm walling had to be done through a very congested area of Chennai Central Station and Egmore. So this was carried out by AFCONs, and we were advising them in various instrumentation monitoring of the construction. So this is just a plan of the Chennai Metro. Chennai Central Station is here, this Marina Beach. And there are 3 lines, Chennai to Padi, then from Padi to the airport. And then one comes through the Mount Road, Saidapet to the airport. Now, this section alone is underground, here and here, whereas all other sections are elevated. Wherever elevated section is possible, we go for elevated because it is cheaper compared to the underground station, underground metro. I'll be discussing mainly the issues related to underground section, and this typical section of the underground station. You have the top overburden of about 3 to 4 meters. This is required to accommodate all the underground utilities like drainage or cable trenches, which may be going through that area. And you may not have any space in the sides because there are buildings on both sides or other facilities. So normally you have the overburden, then you have concourse slab where you have concourse floor, where you have the offices for ticketing, etc. At lower level, you have the platform and the railway tracks. So only one of the underground station at Chennai Central. This has 2 lines meeting at the same point, which is at 2 different elevations. And this is the largest railway station in Asia in terms of its length, its depth, and all other features. You may not be able to read much details in this slide, but this is the Chennai Central Railway Station. And the Victoria building, I'll show you a picture of this. And then we have a Repan building adjacent to it. And the entire station is covered from beginning of the central station to end of Victoria building. And the diaphragm wall required for this is passing very close to the foundation of some of these heritage monuments like Victoria Building, Siddiqui Sarai on the opposite side, and so on. So we had to provide extensive instrumentation comprising of settlement gauge, piezometer, inclinometer, load on the struts, etc. I will discuss it later. So this picture of Ripan building next to the Chennai Central, many of you would have seen the building. It's a heritage structure, very beautifully designed, and it has large floor height. Though it is a 3 floor, the height is more than 15-16 meters. The diaphragm wall is passing just few meters away from it. There was a concern whether excavating the diaphragm trench will create any issue with the stability because this is not on pile foundation, it is on shallow foundation built more than 100 years back. So you can see here the diaphragm wall constructed and excavation started. There's a joint between the two diaphragm wall panel, and we discussed the problem of cover. You can see slightly reinforcement getting exposed here. So all this will need a special treatment to treat the steel and put micro concrete to protect it from future corrosion. The other problem in diaphragm wall trenching is collapse which takes place during that trenching. So you see extra concrete here, which is projecting from the face of the diaphragm wall. This should not have been there if collapse has not taken place. But because of the collapse, you have extra concrete consumed here, and now you have to cut it and remove it. So these are the photographs of Victoria Hall from 4 different sides. And one of the side where you see the barricade in this picture is the face where diaphragm wall is inserted at hardly 6 meters from the foundation of the building. Opposite to Victoria Hall, there's a mosque and a tourist home called Siddiqui Sarai. This also a heritage building, 100 plus years old, with a lot of shops in the ground floor. And the diaphragm wall for the metro construction under this is right on the footpath of this, leaving only 2 to 3 meter clearance from the face of these shops. So all these shops had a very limited access of people to come throughout the construction period of the metro station. Another important heritage structure is the Law College building, which is not at Central Station but at Paris Corner. It is next to the existing High Court there. And this Law College building has a beautiful arch for its entrance. And during diaphragm wall trench, which was only a few meters away from this foundation, certain cracks were seen in this arch, so which raised an alarm, and extra precautions were taken by additional grouting in the foundation before the work had progressed. So this is the grouting machine used for grouting coiled around the diaphragm wall. So as I told you, the trench operation is more serious for collapse compared to board cast in situ pile because of the section is rectangle, which has a flat surface, and the collapse can easily take place. When you have a shallow foundation very close to the trench, there are chances of additional settlement taking place if collapse takes place in the wall, or if there is a piping taking place under the diaphragm wall teeth when you do the dewatering. So it was necessary to have extensive monitoring of the building. So each of the heritage buildings were monitored prior to the taking up the construction with instruments such as settlement markers, settlement, the tilt meter, crack meter, extensometers to measure settlement at different depth, optical prism to check the alignment and level at higher elevation in the building, piezometers or pulsars in the ground, and vibration monitoring during execution of tunneling. So while fixing the instrument, the criteria were decided when you call that the value measured is in alert level, action level, or alarm level. So these parameters are fixed as you see here. The green line indicates alert level. This is for the vertical settlements. If the building settlement is more than 10 millimeter, it's an alert level. It is more than 16 millimeter, it is an action level. And if it exceeds 20 millimeter, it is alarm level. And these are the recorded settlement at one particular location. Similar monitoring is done at number of places. I'll show you some more result where it has reached some of these limits. For example, this is also settlement in one of the measuring point. This is each of the line indicates one measuring point, and at some location, as you see here, it is reaching the alert level. So you have to take some corrective measure, convince CMRL that this will take care of further settlement, and then proceed with the work. Similarly, crack width meter measures the width of the crack, and these are the limits for up to 2.5 mm alert level, up to 4 mm alarm action level, and beyond 5 mm it is alarm level. So I will skip these slides. These are the measurements of different parameter. Some places it became very close to the alarm level, and extensive grouting had to be adopted to prevent further movement. I'll now show you some of the pictures when the metro construction was carried out. This is the location where we call this as a bottom-up method, where after constructing the diaphragm wall, you provide strut as you go deeper, excavate the entire soil out, and then start construction of the permanent from the bottom, pillars, higher level slab, and come up. It is called bottom-up method. This requires lot of struts, and you have to carry out the work between the struts, as I was mentioning earlier. So this is the location where the trenching equipment, the tunneling equipment, is lowered down from the ground level. It cuts the diaphragm wall at predetermined location, and then tunneling advances to the next station. So I discussed two types of method. We'll see the top-down method where we don't need struts to be provided, but the diaphragm wall is supported by the floor of the station itself. So it is something similar to this. I think what we do is divert the traffic and insert the diaphragm wall panel first on either side, so the traffic should be diverted elsewhere, complete. So what you see here, one side is the diaphragm wall, other side is not diaphragm wall, it is only a pile borehole made with a steel section embedded in it. So what you see, this gray color is a steel section. It is concreted in the portion below the bottommost raft of the station. So this is not a continuous diaphragm wall. This total width you see here is only half the width of the station. Another half width of station is to be built on this side, and this is the entire 6-lane road on the top. So you have to have certain area available for traffic to move. So you are diverting traffic only from one side, constructing one side partly, as you see. So after this diaphragm wall and the column is inserted, you put a temporary seat pile, what you see in blue color here, and then after diverting the traffic, remove the soil here, as you see here. And then you cast the slab, horizontal slab, which will support the overburden on one side on the diaphragm wall and other side on the steel column, which was inserted through the piling hole. So these typical columns are every 6 or 8 meters center to center. It is sufficient to support this slab and the weight of the overburden over it. Once this slab is cast, you can have another seat pile installed and backfill the soil. And now you can take up the work on the other side. The traffic can be moved back to this side because you have backfilled it, and then insert the diaphragm wall on this side. And excavate this portion. Again, support the RCC slab, one side supporting on diaphragm wall, other side on the steel column. Okay. This slab will have an opening because whatever excavation you make below this has to be taken out through this opening. So this slab acts as a strut which is supporting the diaphragm wall. You don't need any structural strut, and then you start excavating below this slab to the next level. If you want more space for construction equipment, you can fill this soil partly with a seat pile around. So the excavation is carried out with excavator which can work in this headroom. It is lowered into the excavation. Soil is taken out from this opening. And then the next level slab is cast. Again, one side supported on diaphragm wall, another side supported on the steel column. Again, it has an opening to go to the third level. So you carry out excavation, provide the bottom slab. So after this slab is cast, the steel column was sufficient only to take the self-weight of the slab and certain live load, but not for the full load. So you have to encase this steel column with additional concrete and steel, so it becomes permanent column of this station. And now this section is complete. You can provide the rail track and the platforms as required. Once that has been completed, you can block this temporary opening made and fill the soil and restore the traffic by completing the new road surface. So you have a station completed over the entire width of the road with partially disturbing the traffic. And then the traffic is restored. Whereas in the bottom-up method, you need to have the struts, shift the traffic to one side, insert the diaphragm wall on both sides. You can have again the steel column in the center because otherwise the strut will have a very large span and it will have a buckling problem. Then you start excavating from the top and provide a temporary floor here, steel floor, so that traffic can be moved over it. and then you take up the other excavation. Have a steel strut, because without strut you cannot excavate deeper. The diaphragm wall will not take the large bending moment. So all these red color support are struts between the diaphragm wall and the column. Once you reach the final level, you cast the base slab of, of concrete and then raise the permanent RCC column in the middle and then cast against the formwork staging the intermediate floors, move the construction up. This is called bottom-up method. So complete the entire station like this. Then have the overburden soil over the floor slab. And then complete the so that traffic is diverted. So this completes the underground station over the 6-lane road.
Hello.
Hello, sir.
Is there any problem, sir? Anybody want to talk about our sir?
Yeah. Hello.
Hello.
Do I have
Sir,
more?
good evening, sir.
No.
This is Raman Naik, sir.
Yes, Ramnanak.
Sir, it's a highly appreciable presentation, sir. We are thankful to Professor
Still,
Sir Gandhi.
still presentation not completed. Some problem is there. That's why.
I see, I see.
Sir,
No,
please,
no,
sir.
there is no problem. I want to know, can I take some more time or it is?
Sir, endowment lecture almost already you are taken 55 minutes, sir.
Okay.
You please
Okay.
complete within 4 5 minutes. Conclude, sir.
No, I'm just showing you some picture where a basement of a building is excavated.
Okay,
I
please
just-
show, sir.
I'll just run through
Okay.
the site, which will give you some idea, and I'll not describe the work. Maybe some other time. Are you able to see my sharing?
Yes, sir.
Right?
The screen is closed, sir. Now.
1 minute. I look.
Sir, please conclude, sir.
Yeah. I think it is not coming up. My screen is not coming up. Okay, I think I just wanted to. Are you able to hear me?
Yes, sir. Yes, we are here too.
So I just wanted to highlight how difficult it is to do a diaphragm wall excavation in a congested area very close to important heritage building. what type of monitoring is required to make sure that the building is not distressed unduly and can become dangerous. We had very severe cracks in some of the buildings which had to be carefully handled, and CMRL required regular monitoring of these instruments, reporting every month, and a review every regular period, which made it possible to do the project successfully. So I'll be happy if there is any question or a comment on any of the presentation.
So generally for endowment lectures, no question answer, sir. Now only some of our senior engineers want to talk about today's endowment lecture, our RAO, sir. Now there is in chat box, we Jambal Reddy, you want to talk about today's endowment lecture. Please go to Jambal Reddy, sir.
Good evening, everyone. I am Jambul Reddy, Engineer-in-Chief retired and committee member of the Institute of Engineers. So, Professor Dr. N.V. Nagaru, my guru in the geotechnical engineering. I did my geotechnical engineering in the year 1974 to 76. So, Professor N.V. Rao Garu, Professor Babu Rao Garu, Professor Ramakrishna Rao Garu, Professor Vaikuntham Garu, all the persons in the soil mechanical geotechnical engineering. So, I don't want to take more of 2 to 3 minutes only. So, my guru, N.V. Rao Garu, very simple person. He used to wear only white shirt and white point and white ambassador. So by seeing Professor Rao Garu, he is a very disciplined man. He used to take class to on time only. So we will not make 1 minute also late. So he's very highly disciplined person. So a very simple man, very honest person. So I know I learned so many disciplines about them, so many things about Professor Rao Garu. He's a thorough gentleman. So I want, he's always happy. You know, I never seen any day unhappy. He's always happy, smiling face. He's a very dedicated person. So I'm very pleasure to work under him. I studied under him. So Professor Babu Rao Garu, Professor N.V. Rao Garu, Ramakrishna, all persons I really enjoyed, sir. I'm very grateful to you, sir. థ్యాంక్ యూ డాక్టర్ ఎన్వీ రావు గారు. మీరు 100 ఏళ్ళు కంప్లీట్ చేయాలని భగవంతుడు ప్రార్థిస్తున్నా. నాకు అవకాశం ఇచ్చిన చైర్మన్, ఇన్స్టిట్యూట్ ఆఫ్ ఇంజనీరింగ్ చైర్మన్కు, సెక్రటరీకి అందరికీ నమస్కారం తెలుపుకుంటూ సెలవు తీసుకుంటున్నా. థ్యాంక్ యూ వెరీ మచ్. థ్యాంక్ యూ. థ్యాంక్ యూ.
Sir, now today we are having our Professor D. Babu Rao sir also there, sir. Please talk few words, sir, about the Dr. N.V.R. Rao, sir. Over to Babu Rao, sir. మీరు అన్మ్యూట్ చేసుకోండి, సార్.
Hello.
Yes, sir.
Good evening to all. Thank you, Professor. Thank you, Mr. Chairman. I appreciate the excellent talk by the reverend speaker. I just wanted to make a comment that we have just finished in Hyderabad, a fairly big metro. We did not have any trouble. We did not have any problems, by and large, because Hyderabad is almost a rocky strata. Going back to Professor N.V.R. Rao, we were colleagues for almost from 1971 to 1994. Very recently, Professor Rao has published a book by name Reminiscences, wherein he has very thoroughly outlined his life history all the way from his age of 5 to the age of 85. I have a few copies of that. I would like to send them to the Institute of Engineering Library. I'm also sending them here and there. But as my student Jambul Reddy has just now said, Professor Rao has been a white car, white shirt, white pant gentleman, and white in his mind, and absolutely flawless. And even today, in spite of his age, he continues to write books about a number of things. He's a great Rishi and Maharshi. Thank you very much.
Today we are having our Professor Director Ramna Rao sir also there. Please, if you want to tell anything, sir, please talk, sir. 2 minutes.
At the outset, I would like to thank Professor Gandhi for accepting to deliver a wonderful lecture, a lecture on the problems concerning metro construction, underground construction. In fact, he readily agreed when I called on him. happy that good response is there, and we really enjoyed the lecture for the last 1 hour. I'm also happy that many of my father's old acquaintances are attending this lecture, and in fact, my father is now staying with me, and his pastime is, of course, talking. He finds something talking, and also he is writing books, even about geotechnical book. Geotechnically, he has written recently a book that is also available. That also we'll send a copy to the library of Institution of Engineers. And then his other passion is to write briefly about Bhagavad Gita and Panchatantra, which he enjoys doing it. Right now, he is now 88 years old. Completed 87. He is into 88 now. And I wish him all the best, and thank
you, sir. Thank you very much, sir. Now today we are having our Somavarapu Satyanarayana garu, our past former chairman TRTC. Please, you can also say a few words, sir. Satyanarayana sir.
సార్ వెళ్ళినట్టున్నాడు సార్, లేడు.
ఉన్నాడు చెప్పండి సార్.
సురేంద్ర సార్ మాట్లాడండి సార్.
ఓకే సార్, ప్రాబ్లం ఉన్నట్లు. Shivaji also there. Shivaji, you want to talk anything? Shivaji garu మాట్లాడతారా సార్ గురించి?
శివ సార్ చెప్పండి, నేను మాటలు
అన్మ్యూట్ చేసుకున్నాను. అందరికీ నమస్కారం అండి. మా గురువు గారి గురించి ముందు ముఖ్యంగా రామేశ్వరరావు గారు, మీకు రమణ నాయక్ గారికి కూడా నమస్కారాలు. మా గురువు గారి గురించి మాట్లాడే అవకాశం నాకు కల్పించడానికి చాలా సంతోషంగా ఉంది. నిజంగా 88 yearsలో కూడా మొన్నే పుస్తకాలు తీసుకున్నాను నిన్న ఇంటికి వెళ్ళి, ఇక్కడ మన రామచంద్రరావు గారి దగ్గర. చాలా సంతోషం. వారు ఇలాగే ప్రతి సంవత్సరం ప్రతిరోజు ఆయురారోగ్యాలతో ఉండాలని చెప్పేసి, చక్కగా ఉండాలని చెప్పి ఆ దేవుని ప్రార్థిస్తాను. మీ అందరికీ నాకు ఈ అవకాశం ఇచ్చడం చాలా సంతోషం. నమస్కారం.
Class, today we are also having our Ramchandra Rao sir, MLC also there. Please, you can also say a few words, sir.
Excellent.
Ramchandra Rao sir.
సార్ కట్ అయ్యింది సార్, కట్ అయి ఉంటుంది.
ఉన్నాడు ఫోన్ లో ఉంది, ఐఫోన్ లో ఉన్నాడు. సరే సార్.
అందరికీ నమస్కారం. మా ఫాదర్ బర్త్డే కాబట్టి నేను భార్య కూడా విజిట్ చేస్తూ మీ అందరికి కూడా జస్ట్ థ్యాంకింగ్ యూ ఆల్ ఫర్ having organized this lecture. So I joined little bit late, but still I enjoyed the company of all who are all close to my father and to my family. And I once again congratulate Mr. Rameshwara for having organized this kind of lecture on this occasion. Thank you very much. And I all the persons who are attending the meeting who have given well wishes to my father, and I thank you once again. Thank you.
Thank you, sir. Thank you, sir. Chari sir, you want to say?
Chairman sir, I want 1 minute.
Okay, sure, definitely wait. Chari sir, మాట్లాడతాను పెట్టినాడు. Chari sir, Anmanta Chari sir, structural engineer. Sir, Ramana చెప్పండి తొందరగా మీరు.
సార్ గుడ్ ఈవినింగ్ సార్. ఐఎమ్ ప్రౌడ్ ఆఫ్ మై గురు డాక్టర్ ఎన్వీఎల్ రావు గారికి పాదాభివందనం. హ్యాపీ దసరా. ముఖ్యంగా సారు మా ప్రాంతవాసి కోదాడ అనంతగిరి వారు వారే కాదు, వారి కుటుంబీకులు కూడా కొండపల్లి రాఘవరావు గారు దాదాపు 100 ఎకరాలు ల్యాండ్ ఇచ్చారు. అక్కడే చదువుకున్నాం మేము. అండ్ వీఆర్ స్టేయింగ్ నియర్ బై సార్ హౌస్. రామచంద్రరావు గారు కానీ రమణన్న కానీ మాకు జేఎన్టీ ఉస్మానియాలో అనేక హెల్ప్ ఇచ్చారు. వీఆర్ వెరీ హ్యాపీ. రామచంద్రరావు గారు సారు రమణన్న మన రామేశ్వర గారిని కలిసి ఉంటాం మేము పక్క పక్కన. మా శివాజీ ఉన్నాడు. అలాగే గౌరవ ఎమ్మెల్సీ గారు మా రామచంద్ర గారితో పాటు సతీష్ ప్రోడం గారు అండ్ మా ఫార్మర్ చైర్మన్ ఆర్టీసీ సోమనాథన్ గారు వచ్చారు. అందరికీ మా బాబురావు సార్కి అందరికీ హృదయపూర్వక నమస్కారాలు. అందరికీ దశ శుభాకాంక్షలు. థ్యాంక్ యూ సార్. ఐ విల్ టేక్ యువర్ బుక్ సార్ అండ్ విల్ టేక్.
Chari sahab, Hanmant Chari sahab. Okay. No, sir. No. Now I'm requesting our Honored Secretary, Sir Rao garu unte kuda suggest message iవ్వండి sir. Today is your birthday, sir. Please give the message to all young engineers and senior engineers, sir. We want to see you, sir. Because of Corona, we are not able to see you in our Usman University ground.
You will go to Warangal, NIT for Ramana.
Yes, sir. Sir, please give your message, sir. Unmute చేసుకోండి సార్. సార్ మీరు అన్మ్యూట్ చేసుకోవాలి సార్. రావు సార్.
Hello.
వినిపిస్తుంది సార్.
Thank you very much for all of you.
సార్ మీ దగ్గరలో ఉంటే కేక్ కట్ చేయించేవాళ్ళం సార్. కరోనా లేకుంటే.
Hello.
ఓకే
సార్ వినపడుతుంది.
I thank all of you.
Thank you, sir.
Kind words at this age. I wish you all good for all of you. Thank you. My speech is not good because my feet are not there.
వేడిగా ఉంది కదా బయట.
బాగుంది అక్కడికి.
నిజమేనా? నాకే బాగా చెమటలు వస్తుంది ఇవాళ మొత్తం.
Okay, sir. He finished his speech, sir. Please go ahead.
Okay, sir. Okay. Now I am requesting our Honored Secretary, please propose a vote of thanks. Vote to Engineer T. Anjaya, Honored Secretary.
Respected Chief Guest, whether I am audible, sir?
Audible, sir.
Respected Chief Guest, distinguished dignitaries on the dais, past chairman, committee members of the IEI Telangana State Centre, joint honorary secretaries of Telangana State Centre, fellow fraternity, media friends, ladies and gentlemen. Before that, I congratulate Dr. NVRLN Rao on his birthday occasion. Hope, sir, we wish you to live you for 100 years, sir. Thank you very much, sir. It gives me immense pleasure to perform the pleasant duty of proposing vote of thanks on behalf of the Institution of Engineers, Telangana State Centre. I am on my own behalf to convey our sincere and profound thanks to the Professor R Gandhi, Director, Sardar Vallabhai Patel, National Institute of Technology, Surat, who made it convenient to attend today's webinar and delivered Dr. NVRLN Rao third endowment lecture on very important topic, challenges in underground construction for Meytro through congested urban area. I also thank Dr. Ramana Nayak, Joint Honorary Secretary, who introduced the chief guest of today's webinar. I also thank the family members of Dr. NVRLN Rao, who made it convenient to attend the webinar. I thank budding engineers and others important guests who have attended this webinar in spite of their busy schedule. I also thank Dr. D. Babu Rao, Professor Ramana Rao Garu, and other dignitaries in spite of their busy schedule. I thank one and all who have attended this webinar and made the webinar success. Thank you, one and all, sir.
Sir, now we are closing this webinar amendment lecture by Janaganamana.
Thank you.
అందరికీ సాయంకాలపు నమస్కారాలు.